Students, let us solve this Irodov problem number 1.51. A rotating disk moves in the positive direction of the x-axis. Okay, there is a disk which is rotating and move along the x-axis. Find the equation describing the position of the instantaneous axis of rotation. Okay, so we have to find the equation of instantaneous axis of rotation. If at the initial moment the axis C of the disk, C means center of the disk, was located at the point O after which it moved. So this is the half part of question. The remaining part is this. With a constant velocity v, while the disk started rotating counterclockwise with a constant angular acceleration beta, the initial angular velocity is equal to 0. So this is the first part. What is the given situation? There is a disk. This is the initial situation where the center of disk is located at point O, which is the origin of coordinate system. Now this disk move with a constant velocity v. Disk move with constant velocity v means the center of disk is moving with constant velocity v. While the disk started rotating counterclockwise with a constant angular acceleration beta. Started rotating means initially the angular speed of this disk is 0, but the angular acceleration is not 0, it is beta. So we have to find the equation of instantaneous axis of rotation of this disk. So how to do that? Now to find the instantaneous axis at any random time t, what will happen? First, this disk is translating as well as this disk is rotating. Initial situation is this, so omega naught is 0 at time t equal to 0. So this is the starting position. Now first consider the translation after time t. So this is the situation when time is t. This disk move a distance x equal to vt, s equal to vt. Why? Because the velocity of center is constant. So the distance moved by the center is x equal to vt. So this center moves a distance vt. So this distance is x and which is vt. So this distance is equal to x equal to vt. Now at this time the velocity of center is still v. Now take any point on this disk. Now take any point. Now I consider the point at the lowest portion of the disk. Now this point have a velocity. What is the velocity? The velocity of this point is due to both translation as well as rotation. So what is the velocity due to translation? This disk is translating with velocity v. So the velocity of this disk due to the translation is still v. But as the disk is rotating, so there must be a velocity of this point due to the rotation. How to calculate the velocity due to rotation? The angular acceleration is constant, initial velocity is 0, and we have to calculate the velocity at time t. So first I calculate what is the angular velocity of this disk after time t. For that I use the equation omega final should be equal to omega initial plus alpha into t. So omega final equal to omega naught is 0 plus alpha, it is given as beta into t. So at this moment the angular speed of this disk is omega equal to beta into t. Yes, this is the angular speed. Now if the angular speed is v and this is the distance radius r, so the speed due to this angular velocity of this point is v equal to omega into r. So the speed is omega beta t. So beta into t into radius r. Yes, this is the velocity of the lowest point. Now, what is the total velocity? To calculate the total velocity, we just sum up these two numbers. So, the total velocity of this point is this, and the magnitude of this velocity is v plus beta r into t. Yes, this is the velocity. Now we have to find the position of instantaneous axis. How to do that? For that, the instantaneous axis of rotation is always perpendicular to the is always perpendicular on a line perpendicular to the velocity. So the initial velocity, the velocity of center is this. So instantaneous axis must be on this line. Instantaneous axis of rotation is always on a line which is perpendicular to the velocity of any particle of the disk. So instantaneous axis must lie on this line. Now, how to calculate? To calculate the velocity of that point, instantaneous point must be 0. Now, this is the velocity of center and this is the velocity of rim. So, it is obvious that if I calculate the velocity of this point, this is something less than this but greater than this. If I calculate the velocity of this point, it is something greater than this and less than this. If I continue this, then you can extrapolate that if I join this line, if this line intersect at this point, this is the instantaneous axis of rotation. This is the instantaneous axis of rotation. So, we have to find this length. Now, name it as y. So, we have to find this length y. For that, I consider this angle theta. If this angle is theta, so in this small right angle triangle, tan theta should be equal to v divided by y. V divided by y. Similarly, in this big right angle triangle, tan theta is equal to this length divided by this length. So tan theta should be equal to, this length is v plus beta into r into t divided by this length, it is y plus r. So this is the equation. Now from this equation I can easily find the value of y. For that I apply first componendo and dividendo rule. How to do that? From this upper part, subtract this part. So v and v should be cancelled and it should be equal to beta r into t. If what I do to the upper part, do the same thing to lower part. So from this expression minus this, so it should be equal to radius r. Now these things equal to this, so from this we can calculate y should be equal to v into r divided by beta into r into t. R and r should be cancelled out, so it should be equal to v divided by beta into t. Yes, this is the expression. Now we have a equation of x in terms of time and we have a equation of y in terms of time, and I want to know the trajectory equation of this axis. So it means that we have to find an equation relating x and y. How to do that? It is very simple. From this expression write t as x divided by v and put this value in this equation. So y equal to v divided by beta into time. What is the time? Time is x divided by v. So the equation of trajectory of the instantaneous axis of rotation is y equal to v square divided by beta into x. So this is the equation of instantaneous axis of rotation's trajectory. So this is the answer of first part. In the next video I solve the second part.